Okay, so I know that I have too many questions, so I'm going to try to start to get through as much as we can in an hour. But so one of the reasons that I follow you as a physician, I think you, well, as you talked about in your last podcast or your 100th anniversary podcast of The Drive, which I highly recommend everybody subscribe to, is that this idea that you hold strong convictions loosely held, which I think is so inspiring coming from a physician who clearly aggregates data, and data is such an important part of your practice. And I actually wanted to ask you about that. But so, which, you know, to me elucidates really your philosophy. I mean, not to put words in your mouth around medicine or how you practice medicine. So I would just love to hear you talk a little bit about your approach and your philosophy around medicine.
Well, I mean, I think that it's just, I think first thing you do is just realize we all have ego, right? And it's anytime we try to deny that, I think there are probably some people who manage to go through life without too much ego. And I respect and envy those people simultaneously. But I mean, I know I have an ego, and I know that my ego can lead to really bad things. It can lead to mistakes. It can lead to ignorance and stupidity. So I think the best thing I can try to do is hack my ego in the direction of doing good. And the best way that I can do that is point my ego or orient it in the direction of knowing the most versus being right. So I think most of us are probably hardwired to want to be right. And when that is where your ego is tethered, you tend to be resistant to information that contradicts an existing view that you have. And I know that because that's true for me. I mean, I'm a human, and so therefore I'm subject to that same pressure. But I think through many years of sort of deliberately training myself to flip that switch, and if I'm going to have my ego hurt me a little bit, I'd rather it hurt me in the direction of at least just try to know the most. And then that way you're not as stuck to a conviction. And if new information comes along and changes the interpretation of something, then you're just going to be a little bit more flexible. And I think that's just a valuable way to go through information, accumulation in life, but especially in medicine. I mean, medicine, the stakes are high if you make mistakes, and you're going to make mistakes. But if we can minimize it, I think this is one approach to it.
Yeah, I mean, it's a vulnerable approach. I think it's a great approach, especially because science changes all the time. Seemingly information changes all the time. And a lot of physicians really do, I think, get stuck in their rightness. And so it's a quality that I really admire. Before we get into some coronavirus questions, which I know everybody's going to want to hear, will you just talk a little bit about, just furthering that a little bit? You have, I mean, it's a supposition because it's just from hearing you talk, but a team of analysts that you work with who help you make determinations about where things are going. I wanted to ask you how you or why you decided to gather a group of analysts on your team and what it is that they actually do and how they inform the way you think about treating patients.
Well, in a former life, so I had this sort of gap between what I do now and when I trained in medicine. And in that gap, I left medicine altogether and I went to work for this consulting firm called McKinsey and Company, and had nothing to do with medicine. I worked in finance and in mortgages, actually, specifically around something called credit risk. So looking at mortgage default rates. And, that's a type of firm where you like investment banking and things like that, you just have an enormous team of quants and analysts. And, that was just one of the richest experiences of my life. It was being surrounded by these incredibly smart people. And you could take seemingly impossible problems to solve. But if you had a team of 20 analysts that you could divide pieces of this problem into, you could sort of solve anything. And so if you fast forward a decade, I'm now, back to medicine. And I sort of had this epiphany maybe 7 or 8 years ago, which was I'm losing my ability to keep up with the reading, as you talked about. I mean, most physicians do try to read medical literature, or, nowadays it's even far more explosive because there's podcasts, there's blogs, there's a whole bunch of other things that actually provide really good information if you can sift through the signal and the noise. And I just realized, like, I'm done, I'm hosed. Like, any competitive advantage I have from one day being able to read and assimilate information is gone because there aren't enough hours in the day. So I went back and hired a former analyst who used to work for me. And then that led to another one and another one and another one. And then I sort of realized, that's the richest asset you can have inside of medical practice, is to have people who don't have to focus immediately on the patient. So our practice is divided into two halves, and it's about equal. I think there's probably 8 or 9 people on the research side and 7 or 8 people on the clinical side. And, you want people that are just thinking every moment about the patient. And then you want another group of people who can take kind of a longer view of problem solving. And in the midst of what we're going through now, I mean, obviously for the past 8 weeks, it's been nothing but coronavirus. We've basically put every project we've had on the back burner. But when we get back to some degree of normal, we'll get right back to working on all the different problems we're constantly working on.
Right. So was that data collection the reason? It seemed to me that when Corona was first sort of started being talked about in the news, you had a slightly more, I don't want to say insouciant approach, but you didn't seem as alarmed as you got. So
yeah, I went through phases, right? So I think, January was me being an idiot and just saying, I mean, I literally remember at one point talking to my team and saying, you know what, I'm not the natural owner of this. Let the other people speak up and be the bearers of knowledge on this. I'm just going to put my head down and keep working on the longevity stuff I'm interested in. And, I sort of vaguely remembered SARS and MERS and H1N1, and they didn't seem to matter that much. So I just sort of, just said none of this really matters. So that was sort of Peter 1.0 in January. And then in February, Peter 2.0 is traveling a bunch. I had to be in Australia for a week, and then I had to go to Norway for a week. And I think that just gave me a little bit more downtime to think. And it was really somewhere in the middle of that trip in Norway in mid-February that I actually kind of pulled my head out a little bit and looked at some data, things that could be more contagious than some of the other viruses that we've seen in the past. And at that point, I just completely changed and got, much more clued into trying to understand everything I could about it. And at that point, actually, I was flying from Norway back to New York. I was supposed to spend a week in New York. I didn't even leave the airport in New York. I just got the next flight back to San Diego. And then from that point on, it was sort of the only thing I was thinking about.
Right.
And by the way, there's a Peter 3.0 and 4.0 in that story as well, because that's the nature with which, information is becoming available to us means that you constantly have to update your point of view.
Yep. And so are people in your practice predominantly relying on you for this kind of information right now? It seems like you guys as a practice have become sort of an epicenter of coronavirus information.
Well, I think we're contributing to it. I mean, the good news is what's been really amazing about this is all the people who have kind of done what we've done, which is this is not their day job. This is not the problem that they have been thinking about for more than a couple of months. But, like us, I think we've gone out and figured out who the really smart people are. I mean, we're not the really smart people. We simply assimilate and aggregate information, but there are people who have thought long and hard about these problems for their entire careers, and it's sort of interviewing those people. I mean, that was sort of the first thing I did in February, was basically opened my Rolodex, which might be my greatest asset, and just I remember on the course of a weekend in February, I must have spoken with half a dozen people, all off the record, because no one wanted to talk on the record about what they really thought was going on. These are people, senior ranking people, in companies in China and places like that. And, that was a huge education. That was, a real wake-up call. And yeah, so I think what we've tried to do is just figure out a way to distill all that information into something that people can digest, but also I think people want some degree of certainty. And they also want to be told when, hey, we can't know the answer to this yet, but we're going to probably have more information in 2 weeks.
And so what do we know about it so far, definitively?
Yeah, well, it's funny. I don't know when this podcast will come out, Gwyneth, because of course what we know sitting here today on whatever it is, Friday, April 17th, is all subject to change in a few days. I would say that as of today, my view is there are two huge scenarios that need to be evaluated, right? So I think where we are today, it is clear to me that the likelihood that this is, going to kill over 1 million Americans this year is exceedingly low. You can never say something is impossible, but I just think that is exceedingly low. And a month ago, I think we didn't know the answer to that question. So that's really good news. I mean, that's to me the most promising thing I could say is.
And is that to do with the distancing measures that have been implemented?
That's exactly the question, right? Which is,
More
if we're sitting
than
here today, yeah, no, I mean, that you're asking exactly the right question. And I would argue that there's a way to know that, right? So to maybe state the question more clearly, is the reason we can sit here today and say, this is still a horrible pandemic. It is still going to result in tens of thousands of lives lost in the United States, hundreds of thousands in the world, but not millions, right? Is that because of the social distancing, which of course, first and foremost has its effect on this reproductive number, or R naught, that people have heard a lot about? Is it more a result of the fact that we overstated or believed that this virus was more virulent or more dangerous than it has turned out to be? Or is it some combination of both of those? And we have to know the answer to that before we can act next. Because if we think that this virus is as deadly as our worst fears were in March, and that the reason we're sitting here 10 times better or 100 times better than we could be because of social distancing, then to relax social distancing would be a strategic error. It would simply basically, give us a second wave of this. And conversely, if we think that the reason we're in this situation is more because the virus itself isn't as deadly as we thought, then we have to sort of think of a smart way to reintegrate. It wouldn't just be, go back to business as usual. We'd always want to protect the people who are most vulnerable. We've learned a lot about who those people are, but it means that, people who are at low risk, people younger than 60, people that don't have other health problems, probably don't need to be locked up.
What is the data set that needs to really be collected in order to make those determinations?
So we're actually, as of yesterday, we have just raised the money to do the experiment to basically answer that question. And what it comes down to is what's called a serologic survey of asymptomatic people. Now, today, a pre-publication just came out that did a very small version of this experiment in Santa Clara, California, just outside of Stanford. So you take, in this case, they took about 3,500 asymptomatic people, and they did an antibody test on them. So this will tell you if this person has developed antibodies to it. And based on the prevalence, meaning how many of those people had antibodies compared to how many people have died, you can get a sense of what's called the infection fatality rate, which is different from the case fatality rate, which is what people have been typically referring to. The case fatality rate is basically how many people die relative to how many confirmed cases you have, which is a pretty selective group. And that small experiment suggests that the fatality of this virus is probably more close to influenza, which again is still a big deal, but it's not a doomsday scenario. So what we proposed 2 weeks ago, and then very quickly put a team together at Stanford, Indiana University, and New York University, is to do that experiment in New York. So kind of a big experiment that will sample broadly in all 5 boroughs and figure out how many people in New York who are asymptomatic have been infected. And if that answer is low, let's just say 5% of New Yorkers who are asymptomatic have contracted the virus, then it's a very lethal virus, and we need to be very careful about reintegration. And conversely, if 30% of New Yorkers who are asymptomatic have already had the virus, then it tells us that the Santa Clara results are probably real and would extrapolate to the epicenter of coronavirus in the United States and potentially the world. So I hope we know that answer in about 3 weeks, by the way.
Wow, that's amazing. Do you have any insights or suppositions around why for certain people, they're asymptomatic and others are, it's fatal?
Such a good question. And I think as time goes on, we'll get better answers into that. It's probably multifactorial. So on one level, I think there's going to be some people that are more versus less resistant to the actual virus. So, there are going to be some people who take a lot of virus on board, and there are probably going to be some people who don't take as much virus on board. Now, that might come down to different receptors that people have on their cells or on certain types of cells that
And
are
would that be
vulnerable.
genetic?
It could be genetic. It could also be a result of pre-existing disease. There are certain disease states where people might upregulate certain types of receptors on cells that make it more likely that they're going to take a higher viral load on. So I think there's probably differences at that level. I think there's also differences in level of immune response. The immune system is one of the most amazing parts of human biology. I've always been attracted to it. That's what I studied, when my postdoc was the immune system. But with respect to cancer, so it was different. The cancer is the adaptive immune system. But here we're dealing with sort of a combination of what's called the innate immune system and the adaptive immune system. And the point is, what you don't want is too much or too little of an immune response. So too little of an immune response means the virus kind of runs roughshod over you and you're hosed. And then too much of an immune response means, yeah, you probably eradicate the virus, but in the process, you damage your own body so much. So I think that becomes a second layer of susceptibility, is where do people fit on that distribution of too much, too little, or just the right immune response. And I think a third factor is the underlying health of the individual, or what we would call physiologic reserve. So, if we said that, hey, everybody is going to, fall off a boat, and in that, when they fall off the boat, they land in the water, and they're going to have to be able to hold their breath for a minute. But if you did that across the population, there's going to be a bunch of people who could hold their breath for a minute like it's nothing. And then there's going to be another group of people who, who've smoked a lot or just don't have the lung capacity or whatever. And for them, they don't have the physiologic reserve to do that. So all of a sudden, the same stress will hurt different people because of their physiologic reserve. And I think we're seeing that here as well. I think that's why we're seeing the older a person is and the more what we call comorbid disease they have at baseline, the worse their outcomes. Although we don't fully understand why. Meaning we don't understand exactly what it is about diabetes, for example, that is making somebody a little bit more susceptible. There are theories, but again, they're simply theories at this point.
I read in the New York Times this morning that I think it's largely anecdotal and it hasn't been peer reviewed, but they said that obesity is a contributing factor to the morbidity rate. Are you seeing that?
We are and we aren't. I interviewed someone on my podcast a few weeks ago, and their strong conviction was that obesity was a big part of it. When we looked at data in Germany and Italy, we saw obesity as a minor risk factor, but not a huge risk factor. It wouldn't surprise me if it in the United States plays a different role than it does in other countries, and therefore over time we'll get different answers. Obesity has different flavors in different countries. So obesity in the United States is very different from obesity in Asia. So the genetics of the population produce a totally different type of obesity. And my view is obesity by itself, meaning just having extra fat cells, is not really what's increasing people's risk, whether it be to cancer or coronavirus, both of which are, certainly that's true in cancer, that obesity is a huge risk. It's the second biggest risk actually after smoking. But I don't think it's the fat cells per se. I think it's the metabolic environment that a person who is obese is more likely to have than someone who's lean. And I think that's probably what's happening here.
Do you think, does obesity cause chronic inflammation in the body?
Well, it's a good question. Is obesity the result of or the cause of? And it's probably a little bit of both. There's no question that fat cells make inflammatory cytokines or chemicals, and that the more of those you make, the more dysfunctional the fat cells are, the more likely you are to get fat. So that's definitely a plausible mechanism by which we would say someone who is, has a higher degree of inflammation at baseline is probably going to have a worse outcome.
Some people say it doesn't matter if, for a lot of people it doesn't matter about underlying health conditions. And like if you take those people out of it, and there are healthy people who have succumbed to this, and there are healthy people who've been asymptomatic. So, do you believe that in the terrain of the body, meaning like its capacity for recovery, its health, its level of inflammation, how well its natural detoxification processes work, et cetera, do you think that those things have an impact on how well we can recover from disease?
Every virus has a different superpower. Again, viruses they're bad actors, right? They're unlike bacteria, where most bacteria are of no harm to us and are actually important to our existence. Viruses are not. Viruses are not necessary for our survival. Now, it's true that many viruses don't really cause us much issue, but a lot of them do. And so, viruses have this evolutionary thing where they need us. They're a parasite. They can't reproduce without a host. And some of them manage to do that and stay under the radar the whole time. And some of them are just so devastating. So to your question, if that's what we put under the bucket of germ theory, there are absolutely differences between, even like, I'll give you an example. We talk about influenza like it's one virus, but the reality of it is each year we have a different flu virus show up. And some years it's a really, really brutal flu. 2017, 2018 was a devastating influenza, probably killed more Americans than this coronavirus will, depending on how this shakes out. So, that's a really bad actor, and yet reproducibly, it kills the same type of people every year. And so that clearly tells us that this other issue you raise matters. So year on year, you'll get a different influenza virus, which tells you there's changes between the viruses that matter. But then you see the same pattern of mortality and morbidity, which also tells you that the host matters a great deal, both in terms of their immune response and then their resilience to cope with the aftermath of the immune response.
Interesting. So in your practice, are there things that you recommend to your patients in order to maintain optimal immunity?
Yeah, we don't really think there's much evidence for kind of, biohacking approaches to immunity. And as much as everyone would love to know that if you could just take this supplement or that supplement, it would all be okay. It really comes down to sleep is probably one of the most potent drivers of immune function. And sleep deprivation then by extension probably renders people more susceptible to a downtick in immune function. When you look at exercise, I think we actually have pretty good literature that steady state, modest exercise is probably in the short run quite immune enhancing, but super intense exercise, though it has a great benefit, in the short run probably taxes your immune system. And so about 6 weeks ago, we actually sort of made that recommendation to our patients, which was, hey, while we're waiting for this thing to shake out, and again, 6 weeks ago seems like an eternity and how little we knew. This thing could have been, all hands on deck, brutal. Our advice was, this is not a great time to do your Tabatas and stuff like that. This is a time to double down on your sort of, zone 2 steady state aerobic activity. And so even though that's kind of a short-term thing, it's worth sort of understanding. I think with nutrition, there's the common sense approach, right? It's hard to quantify, but it's hard to imagine that, eating Snickers bars and chocolate chip cookies is somehow going to do more for your immune system than eating salad. But the reality of it is, I don't think we have quite as much really good clinical data the way we do on sleep and exercise. So I think those are the big three. And then the other one that I also think the data are okay on, but if you look beyond just the immediate data and think more broadly and think indirectly, I think the relationship of stress and immune function can't be overstated. So cortisol is one of those hormones that's essential for life. So, it's not like it's bad, But most of us, certainly I'm in the heavyweight championship category of this, tend to err on too much of it. And that's, I mean, that is really devastating to immune function. So whatever we can do, be it meditation, journaling, walking, all of the sort of toolkit that we can bring to help manage cortisol levels.
What is that toolkit? I would personally love to know.
Well, I mean, I think it's everyone has a different thing. I mean, for me, I think that meditation, in particular, a type of meditation called mindfulness meditation or Vipassana meditation, is a great toolkit. Not so much because it's especially calming in the moment, the way other types of meditation are. So transcendental meditation, which is a different type of meditation, a mantra-based meditation, is, I think, in the moment, much more calming. But I think mindfulness meditation is, for me at least, a better tool in the rest of the day to help give me what I would call is the gap between stimulus and response. Mm-hmm. So, most of us, well, I shouldn't say most of us, I'm hardwired to go from stimulus right to response. My kid throws something at my head, I immediately get pissed off. Like, I don't have that amazing capacity to pause and go, oh, he's cranky because of this. Maybe I should, And so meditation just allows that to be going from 1 millisecond to maybe 2 seconds.
Increase the pause.
Exactly, totally. Although I don't do it consistently, journaling, I think, is really good for people. I go through phases of my life where I journal like crazy, and then I go through phases where I don't.
Why? To process emotion, or?
Yeah, it's just to basically have a way to write down and communicate with a non-judgmental party exactly what I'm going through and be able to acknowledge it in a manner that, for me, it's hard to, sometimes it's just hard to admit to people around me how afraid I am or how weak I feel or all those different things. But I can sort of be staggeringly transparent with my journal. Mm-hmm. And then for me, nature is an essential part of this. So being outside, so archery is like one of my favorite things in life, and just being outside and really removing any agenda. So not like scoring the round that I'm doing or trying to be ultra competitive, but literally just kind of using archery as just an excuse to be outside and to pay attention to my body. So it sort of becomes a sensory exercise.
It's sort of a meditation in and of itself, the way you're describing it.
Yeah, it's a different kind of meditation. It's sort of a body scan meditation. So I think those would be 3 things that for me really move the needle a lot. I think exercise for some people, exercise for me is very important, but I guess it does de-stress me a little bit, but I guess I just think of it as its own sort of category of this. Like I'd probably exercise if it was bad for me. I enjoy it so much. So it's not quite in the same bucket.
But you were a very intense exerciser in the past, right? And now.
Yeah, up until about 5 years ago.
And then, so what changed for you? And will you explain to me what zone 2 exercise is? Because I always hear you talk about it and I don't really know what it is.
Yeah, so there are basically 5 or 6, depending on the category, zones of intensity. So what what's your favorite aerobic exercise? Would it be running, biking, rowing?
I like to dance. Actually, I do dance, dance aerobics, basically.
Got it. And so dancing is a little bit harder because I'm guessing you don't do it at a constant pace. There's periods of high intensity and low intensity, right?
Right. Yes.
Okay, so let's humor me for a moment and pretend that I could put you on a bike instead. Okay. And then we can extrapolate to dancing. So if we put you on a spin bike or just on a regular bike on a stationary trainer, it would be easier than having to ride on the street. There are different energy systems in your body as you move from basically slow rolling to going all out. So imagine there's a pace at which you barely know you're moving. So you could be on a bike right now and I wouldn't even realize it. You're right. You have such little exertion.
I am.
Exactly. I can't even tell. But so you're clearly in zone 1 right now. It's what we call smoking and joking pace. And then at the other end of the spectrum, there's a pace that you could probably only hold for about 20 seconds. And that is completely all out. And these are really, I mean, every person has this, by the way. The only difference is the world's best obviously have a much longer spectrum, and their zones are in different places, but the same physiology holds. Without boring you with what each of the stages mean, zone 2 is a particularly important one from the standpoint of longevity. It's the stage at which your body is most efficiently using these organelles called mitochondria to generate energy. And the currency of energy is this thing called ATP. So we can turn glucose and we can turn fat into ATP. But in zone 2, you are maximally doing that with the mitochondria. So zone 2 is this maximal mitochondrial efficiency zone. And in zone 3, where it gets a little bit more intense, you're still using the mitochondria, but you've exceeded its capacity to be the sole provider of energy. So now your body has to start triggering other types of energy production that produce byproducts, and one of them is called lactic acid. So the sort of easy way to think about zone 2 is it's generally about the highest level of intensity at which you could carry out a somewhat strained conversation.
I'm talking to Dr. Attia.
Oh, wow.
I know. Are you
recording?
We're recording, but is it okay if my husband says hi? He's a fan of you too.
Hey, how are you?
Hey, how are you?
Nice to meet you. Thanks you really got us through certainly the early days, but then throughout. So thanks for what you're doing.
Oh, well, my pleasure.
Have fun, you guys.
Thank you. Sorry to interrupt. Go ahead.
Yeah, no worries. So zone 2 is about the last place where you'd be able to have a conversation, and you'd still be huffing and puffing a little bit, but you could sort of carry it on. By the time you would not want to talk anymore, that's zone 3. Okay. And the reason we care so much about this zone 2 is that's where we really enhance or expand our mitochondrial efficiency.
Okay.
And
is there
so we can train that.
A specific metric that you're tracking to understand when you're in the different zones? Is it heart rate? It's
both heart rate and lactate production. So
how do you measure lactate production?
You poke your finger and you get some blood and you put it on a little strip and it measures lactate.
Okay.
But not everybody does it, but.
Okay. So that would be maybe like a good brisk walk type of thing.
Depending on your level of fitness, yeah. So when I do zone 2 on a treadmill, I put it to the steep setting, which is about 15 degrees, and I'll walk at about 5 or 6, maybe 5.5 kilometers an hour. So a brisk uphill walk would do it. On a bike, there's a certain wattage that you would use, or on a rowing machine, a certain wattage or pace, yeah. And everybody's different, right? I mean, the fittest people in the world, in fact, there was a beautiful study that was done that compared people with diabetes, people who were sort of not fit, people who were fit, and world-class athletes. And the difference between their zone 2 was unbelievable. So this zone 2 was a direct marker of their mitochondrial function. And not surprisingly, the people who were world-class athletes, they were cyclists, had incredible mitochondrial function, while the people with diabetes had basically broken mitochondria.
Interesting. And why is it so important to have good mitochondrial function?
It's one of those hallmarks of aging. If you sort of look across the board at what happens to people when they get older, the mitochondria just become less and less effective. And most disease states have some degree of mitochondrial dysfunction. Certainly that's the case in cancer. Certainly that's the case in diabetes. It's at least for a subset of patients with Alzheimer's disease, there's clearly a broken component of metabolism. And so, when the mitochondria go bad, the organism goes bad. And so this is sort of one way to not stress the mitochondria too much, but provide this sort of overall baseline of health and sort of support as we continue to age. And since I'm not training for a sport anymore, I don't have to spend as much time on some of those higher energy zones that were much more geared towards performance.
Mm-hmm. So just while we're on mitochondria, do you use NAD at all in your practice?
No. We do have some patients who take NR, which is so nicotinamide riboside, or NMN, which are precursors to NAD. But at this point in time, I'm still really unconvinced of the efficacy. As you probably know, to take NAD probably does nothing, because NAD doesn't really get into the cells that well. So if you want to have any chance of getting more intracellular NAD, you have to give a precursor. And again, NR and NMN seem to be almost interchangeably, though NR is more commercially popular. There's two really huge companies that make a ton of this nicotinamide riboside. But when you really look at the data, and we've looked at this 10 Ways to Sunday, I think I've done 3 podcasts on the topic. And of course, in preparation for each of those, each time I've gone back and reviewed the literature, I just can't make a very compelling case that it moves the needle much. The good news is I don't think it's harmful. I think that's always got to be the first question you ask when you're contemplating taking something is there a chance this is harmful?
Isn't that the basis of medicine? Isn't that the Hippocratic Oath?
Yeah, more or less. But I think it's too soon to tell. Now, the good news is there is a study that is going on right now that will be the most rigorous study ever done looking at it. It's called an ITP, so it's a multi-center NIH trial looking at, so it's using multiple labs, multiple centers, looking at NR, I believe it's using NR and not NMN, to look at longevity in mice. And this will be a very important publication, and it's due out either in the summer or fall of this year. So I'm eagerly looking forward to the result of that study. To put it in context, there are only 2 drugs that have ever gone through the rigor of the NIH ITP study that have actually shown a longevity benefit. So it's a super high bar.
And what are they?
One of them is Rapamycin, which had by far and away the biggest effect. And Rapamycin's sort of my favorite drug out there. And then the other one is called acarbose, which had not as, it's a drug that prevents you from absorbing glucose.
Okay.
Yeah.
And Rapamycin, do you take yourself or do you prescribe it frequently? And what is it?
I do take it, but I don't prescribe it frequently.
Why?
I think I'm still kind of working out some of the kinks. It's funny, with all this COVID stuff, one of the most important questions I've had about Rapamycin is, what is the impact on the innate immune system? So we know that Rapamycin, when it's pulsed, which means not taken every day, but maybe taken once a week, enhances adaptive immunity. That was demonstrated really elegantly about 5 years ago using an analog of Rapamycin called everolimus. So they took a bunch of people, I think they were about 60 or 65 years old, and gave them different schedules of Rapamycin, and then gave them a flu vaccine and looked at T cell response. So that's an adaptive response, and it was stronger. That's huge news. What we don't know is the impact on the innate immune system. And that would be important to know, because the innate immune system is the one that immediately generates antibodies and immediately combats, without the T cell, a pathogen. And so I think I'm pretty confident it is not deterring the innate immune system, confident enough to take it myself, not quite confident enough to prescribe it to others yet.
I like that you always seem to guinea pig all of these so-called longevity drugs before. The same happened with you and metformin, is that right?
Yeah, I think I started it pretty early. I started it in 2010, but I stopped it as well in 2018. So
why did you stop?
Because it was actually impairing zone 2 significantly. Yeah, metformin's a mitochondrial toxin, which is a good thing if your mitochondria are really defective. Taking a little bit of a toxicity hit to the mitochondria produces a lot of other benefits. That is why metformin is such a great drug for people with type 2 diabetes.
Right.
But I began to question sort of how valuable it was in people that could otherwise be healthy. And I don't think I know the answer yet. In fact, I've got a podcast coming up in a couple of weeks to revisit that question on metformin.
Interesting. So how would you define a longevity practice?
Meaning, like, as an individual who wants to put into practice all the tools of longevity, how would they think about it?
Yeah.
I think one has to kind of come up with their own definition of longevity. So I don't want to superimpose mine on others, although for my patients, I sort of offer that as the framework, which is, longevity has these two pieces, lifespan and health span. So lifespan is the living longer part, and health span is the living better part. And then it's basically double clicking on each of those and understanding what it means. So living longer, it turns out, means delaying the onset of chronic disease, not living longer with chronic disease. So there's a clear distinction between those. And I think the answer is unambiguous, which approach works.
Right.
So if you want to live longer, you have to delay the onset of chronic disease, not, get it at the same time and figure out a way to survive it longer. And so then you sort of go down the path of what does it mean to delay heart disease, stroke, cancer, Alzheimer's disease. And then health span, everyone has to kind of come up with their own way of thinking about it. For me, it comes down to cognition, physical, body, and emotional health. And the last one isn't really that tethered to age, but the first two definitely are.
So in your own life, I know, meditation, journaling when you can, archery, exercise. What about the diet piece? I really want to know what you eat. Take me.
Well, I mean, I think of my sort of framework around nutrition is that there are kind of three big levers you can always be pulling with food. One of them is called dietary restriction. One of them is called time restriction. And one of them is called caloric restriction. So DR, TR, and CR for short. So DR just means restricting certain things within the possible spectrum of diet. So a vegan diet would be a form of dietary restriction, a paleo diet, a Mediterranean diet. Basically, any diet anybody's ever described is just a form of dietary restriction. Time restriction says it's not so much about what you're eating, it's when you're eating. It's taking the window in which you eat and compressing it. So and people refer to this as intermittent fasting, but I think the term time restriction makes more sense. So, some people, the most common way people would think about this would be 16-8. So 16 hours of not eating, 8 hours of eating. That would be a time restricted feeding. And then the last one is caloric restriction, where you're actually just restricting quantity. And that can be, restricting it a little bit to completely restricting it, which would be fasting. So my approach to nutrition is basically always be doing one of those. Sometimes or often do two of them and occasionally do all of them. So, I generally do a 3-day water only fast every month. And then I'm usually doing time restricted feeding and dietary restriction all the other times.
Yeah. It's amazing when you really start to read about what during that time, the chance you give to the body to detoxify and recuperate. And I'm a big
Do you
fan.
fast?
I do. Yeah.
Yeah.
Yeah. It's funny. I naturally don't eat in the morning. When this all started to become like a buzzy thing, intermittent fasting or whatever, however, that's how it was culturally described. I realized that I do that anyway. Mm-hmm. I like to eat dinner early and I never eat breakfast. I've never liked breakfast. And then sometimes I'll do, something a little bit more calorie restrictive just to give myself a good rest. I could use that right about now in the quarantine. I don't know what my target weight is here, but I think it's about time to calorie restrict.
Yeah, I started out this year with a goal to sort of drop about 7 pounds, which my aspiration was around race car driving and go-karting, because that 7 pounds is in a go-kart is a lot of extra weight. And I had made a ton of progress until the quarantine, and then I erased all those gains. So
it's impossible. I actually thought about starting a fast last week, and I was like, I think I will genuinely kill someone or myself if I'm.
Well, you should join me, because so I'll shamelessly plug an app I'm a part of called Zero, which is a fasting app.
Wow.
Yeah. So Zero fasting, and we've been doing, and we've got about 1 million users, and every Sunday we've been doing 1 meal a day going into Monday. Because again, the point is, I don't have it in me to do 3-day fasts right now, and frankly, I don't even know if it's a good idea, because again, long-term fasting also raises cortisol, which probably in the short term is harmful to the immune system. So our view is, hey, it probably doesn't make sense until this thing resolves to restrict long-term fasting. But I also noticed even things that I would take for granted, like just eating one meal in a day, which is normally trivial for me, was impossible during this quarantine. So then I just said, look, we got to come up with a way to do this like with 1 million people so that I will get through it, because otherwise I'll cheat and I'll start eating at 1 o'clock. So we've been doing this every Sunday. I go Sunday night to Monday.
And what does the app help you do? Just put it.
So it's got a timer and it's got a whole bunch of other, sort of data and stuff in there to help people log stuff. But for me, frankly, the best part of the app is seeing how many other people are fasting at any moment in time, and connecting with people socially through that, so that I don't.
Moral support.
Yeah, exactly.
You can't really fail on a fast if you've declared it to your community.
Yeah, can't do it.
You have to stick with it.
And I tell my kids, so they will never let me violate.
That's so funny. Okay, before I let you go, I just have a couple more questions, which I read in the Wall Street Journal that there were some intelligence officials claiming that COVID-19 was man-made in a lab. What are we supposed to think when we read stuff like this?
I didn't see that story, but I've certainly seen many others that have talked about that. Again, if we want to be completely intellectually honest, we have to have some degree of humility, and we have to say you can't just say that is impossible.
Right.
So you have to reserve the right to believe that, yes, that could be the case. I do think the overwhelming evidence suggests it is not the case, though. That this is not something that was man-made and nefarious, but rather Occam's razor is the explanation here. This is a virus. This is a family class of viruses that are not unique to our species, not unique to our planet, and every once in a while, they manage an escape. And again, the escape is, do they escape from animals and get to humans? And that happens, by the way, quite frequently. The good news is usually it stops there, and it's just animal to human. What made this one such a problem is it also had amazing human to human spread. I also just think, I think most people don't appreciate how hard genetic engineering is. And I used this example once, I think, talking with a friend. I was like, we've had 25 years of genetically engineering crops, and what do we have to show for it? Like pretty much nothing, right? Monsanto has pretty much accomplished nothing with genetic engineering. We have not really improved the yield of crops. Yeah, we've made them more pesticide resistant, but it hasn't really moved the needle. So the promise of GMO has been largely unmet. And also the promise of genetic engineering, like how we've been 28 years now trying to manipulate viruses genetically to cure diseases. I mean, we've got almost nothing to show for that as well. It's not to say we won't have something to show for these things. I think we will, but these are really hard problems. So I still just have a hard time believing that, some rogue cell of scientists have been able to create this coronavirus that's so perfectly able to do what this one's able to do. So again, I'll reserve the right to change my mind if new evidence emerges, but my intuition is that that's just a typical human response of, we don't want to believe Lee Harvey Oswald shot JFK because he was such an irrelevant plebe, and how could one lone idiot have altered the course of history? But that's how random events occur.
Yeah, unless you watch Oliver Stone's JFK, in which case there's a whole other explanation.
I know, except the problem is every one of them was a lie. Like if you go back and actually look at the facts, like Oliver Stone took the most ridiculous liberties of all time and just like literally made up a bunch of stuff for dramatic effect.
Yeah, well, it made it for a good movie.
Great movie, science fiction.
So I know there are also I think you're helpful for clearing up some of these conspiracy-like theories. And look, maybe some of them will turn out to be true, but people were reading about, people testing positive in Asia and then recovering and then getting sick again or testing positive again. Talk a little bit about that.
Yeah, this is important because I think it is a bit too soon to tell. We have different ways that we can test people, of course. So The most common first type of testing that was done for people was something called PCR testing. So that's sort of the gold standard of testing, but it can only tell you when someone is actively infected, and it's looking for actual viral RNA. And so you had this whole first wave of people who tested positive via this PCR test. The assumption would be then, hey, those people went on to develop a lasting immunity, just the same way you typically don't get the exact same virus again. You know, you'll get a version of it, but usually once you've had a virus, it doesn't come back. And if it does, it's a long time later. For example, you know, getting, if you had chickenpox as a kid, you can still get shingles when you're an adult, which is the same virus actually being reactivated in your body. It never leaves. And then of course we have antibody tests where we can measure, you know, antibodies in people. And that gives us a sense of, oh, they had this thing called a humoral response. They made these immunoglobulins, et cetera. But we are noticing a couple of things, right? We're noticing that one, there are differences in response by people. So if you took 100 people who definitively tested positive and you measured their antibodies and then measured them again and again and again, you would see different levels. So we don't actually know how long standing it is.
Is there a ratio between severity of symptoms and production of antibodies?
You know, that's a good question. I don't know the answer to that. There's definitely a time course to the antibodies. So the two that we talk most about are IgM and IgG. And the IgM antibodies typically show up within about 5 days of infection. They kind of go up and then come down. And while they're coming down, the IgG is coming up. So the IgG is the one that if somebody was infected 2 months ago, you would assume that their IgM would be gone by the time you test and their IgG would be. A lot of the tests for that are not quantitative. So they can't tell you how much is there. So there's some tests that can count the amount and others that can't. But no, I don't know if the amount of immunoglobulin would directly correlate to the severity. I think that would be probably more multifactorial, function of viral load, cytokine response, underlying host health. Studies of primates have suggested that if you infect them with this virus, they are not susceptible to reinfection. But again, those are very small studies. My intuition is that this is one of those things we're going to have to figure out in the coming months. Because this is coming back, right? Like I think if you consider what happened in 2002 and 3, and if you basically look at the last 20 years, anybody who thinks that we aren't in for lots more coronaviruses in our lifetime, I think just fails to appreciate probability theory. So this is going to come back. I think this is a good dress rehearsal for how bad things can get, but it can also get a lot worse. And I just hope the next time it comes back, we've figured out, I mean, I think it's pretty clear what the mistakes have been. I hope we don't forget them. And I hope we kind of do things a little bit different, especially with respect to testing.
Will come back like in the fall or will it have mutated?
That's a good question. I definitely think this strain, so I think SARS-CoV-2 is probably never going away. I think it will probably become the 5th seasonal coronavirus. So there's about 4 of them that we've constantly been shuffling through. I think this probably becomes the 5th seasonal rotation. Does it ever mutate and acquire a whole new set of properties that makes it really bad? Maybe. Alternatively, maybe another coronavirus emerges or another flu virus, either avian or swine. Historically, the worst viruses our species have seen have been influenza viruses. So obviously the worst of those was the 1918 swine flu, was devastating. And then we also had a couple avian flus in the 60s and the 50s as well that knocked out about 3 million people.
Right. Well,
really uplifting discussion.
I know, I'm sorry. Well, this is what people want to know. I want to know as well. But you would say right now the likelihood that if you had a positive COVID-19 test, the likelihood that you would be reinfected, both in the near and short term, would be what? I mean, the near and long term.
No, I know what you mean. I think the likelihood you'd be infected with a high severity is probably lower. So in other words, even if you are reinfected, it's probably the case that you would function like someone who received an attenuated vaccine. And so you would be able to mount a quicker response. And remember, that's how vaccines work, right? The idea of a vaccine is you give somebody enough of this thing that they develop the humoral response to it. And then if they ever see that virus, they jump all over. That's why, kids don't get chickenpox nearly as severe as their parents did. Like I had, I was destroyed by chickenpox. When my kids got it, it was a walk in the park because they had a vaccine to it, so they could get a really quick response. So it might be the case that people who have been infected either don't get reinfected anytime soon, and if they do, it's really mild.
Right.
That's the hope, at least.
Well, we're out of time. I could continue to ask you questions for hours, but thank you so much so what is the app that I'm downloading when we hang up?
Oh yeah, you join me on Sunday for the fast. It's called Zero Fasting.
Zero fasting. Okay,
Yep.
I'm gonna do that. Thank you so much, Dr. Attia. It's been a real pleasure, super illuminating, and you're just wonderful.
Thanks for having me on.